Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose science, technology, engineering, and math. And this evening, I want to talk about structural design and what goes into structural design. Now, structural design can be found in a few areas. Found in architecture, civil engineering, interior design. Now, generally, when we deal with structural design, if you're a civil engineer, we deal with the American Society of Civil Engineers, 7 code specifications. And of course, if you are in architecture, you deal with the AIA specifications. And there's also one for interior design. Now, some call interior design interior architecture, which the purpose of interior design is you basically design everything on the inside of a building. Interior designers, you would find a lot of them in some of your hotels. Now, I will tell you this, when we deal with structural design, you have to understand calculations. You have to understand the software like STAAD, which is a CAD software for structural engineers. You need to deal with safety factors. And one manual you're going to have to use, and I'm just going to take most of this from a civil engineering standpoint. You have to utilize it's a big black manual. I used to have a green manual from the ASD times, but AISC, which is the American Institute of Structural Construction, they have a big black manual. I paid $350 when I was at undergrad school rather, and that manual tells you everything. And if you're taking the FE and the PE examination, you're going to deal with structural engineering. You need to understand what the codes are. You also need to understand dead loads, live loads, wind loads, snow loads. Very important when you are doing a building. Now, earlier I talked about foundations and footings. Well, it's also part of structures of soil, whether you are in architecture or you're in civil engineering. Now, basically, your architects certainly they do a lot of steel design as well, but architects mainly put some art behind what they do. When it comes to the inner core of a building, the actual structure, civil engineers, they have to do that because you're dealing with columns, you're dealing with beams. Depending on what types of structures, you could be dealing with joists. You're dealing with a lot of parts to basically give support to that building. Or if you are in transportation, now some people call bridges structures, some call it transportation. I call anything that has to be built up vertically a structure because a bridge is a structure. And there's some wonderful bridge structures out here like the Golden Gate Bridge, the Chesapeake Bay Bridge Tunnel, the Fort McHenry Tunnel that runs under the Patapsco River in Baltimore, the Tuscarora Tunnel that was bored through mountains on the Pennsylvania Turnpike in Pennsylvania. You have the Verrazano Narrows Bridge, and one of the oldest bridge structures out here, built right back in 1855, was the Brooklyn Bridge. And then you have the Twin Towers in Dubai. And these are all engineers that actually developed those structures. Now, what you have to understand about structures, you need to understand your forces, you need to understand moments, you need to understand structural analysis. Is your structure statically determinate, which has the same amount of unknowns and moments, or is it indeterminate, which generally you have to take a structure. There's really no such thing as a actual-wise a statically indeterminate structure, because if you had a statically indeterminate structure, somewhere along you got more moments than unknowns, or more unknowns than moments, and that structure would basically collapse. So basically, we take a statically indeterminate structure and make it determinate. You have your shear and moment and your bending diagrams. This is all part of structural design. And then you have to look at what material you're going to use for your structure. Now, let's get in here and let's do more of talking about structural design here. Just bear with me. Here we go. All right. How to implement structural design principles. Again, much like a structure or much like architecture, let's start off like that because we're dealing with the building now. But much like architecture, structural design plays a pivotal role in ensuring stability and integrity in project management because it forms the backbone of any successful project by making it crucial for project managers to understand and effectively implement these principles. But where do you start? And how do you navigate the complex landscape of structural design? And that's where you are going to deal with structural engineers and project managers. In this article, it's basically, if you're in construction, it is tailored specifically for project managers or construction managers. And what this information is going to do is provide an overview of structural design. Because what I'm going to do, I'm going to get into the basics and I'm going to help you get through the steps to implement a robust structure for projects. And basically, they're going to be case studies that highlight innovative designs and challenges in the field. Now, what I'm going to say this, whether you are a seasoned project manager or just starting, one thing you need to know about structures is you need to know about the calculations and how they work. So let me say this. I'm going to make this short. Before we even implement structural design in any project, I'm going to take a moment to get you to understand the basics. So much like the skeleton of a building, when we deal with structural design and project management, it basically refers to the framework that holds the project together. So project management or construction management, you'll understand how a building is put together. And you have to understand that structural design is a complex process that requires a deep understanding of physics, mathematics, and engineering principles because it concerns the development of a framework that can withstand loads and forces while maintaining its shape and stability. And it also involves analyzing the structural components, materials, and systems to verify the structure's performance and safety. So basically, when we talk about structural design, engineers must create a design that will withstand elements such as gravity, wind, seismic activity, and other forces. And that's where I was telling you about the loads. You have different loads, or we call them environmental loads. So the key components of structural design, because I've already given you the basics. So now I am going to go into the subject a little deeper because in this section of the lecture, I'm going to explore key principles in construction design. And you have to think of these principles as guiding rules or golden rules that are going to help ensure that your project structure is sound. So here's what I'm going to do. I'm going to uncover the basics for you right now. And let's start off with a few of them. I'm going to deal with load bearing capacity. That is the ability of a structure to support loads and forces. Then we have stability. Stability is the resistance of a structure to overturning, sliding, or collapsing. Then we deal with strength. It's the capacity of a structure to reduce a correction. Well, forces, you have to have forces. So let me repeat that again so there are no misunderstandings. When we deal with strength, we deal with the capacity of a structure to resist applied forces without failure. So I could have said we can reduce failure by making sure that we have a good structure in place to resist applied forces. And then we get into stiffness. Now, there are courses called stiffness methods for structural engineering, and they involve differential equations. And that's probably where you're going to see differential equations in civil engineering, probably the only course, stiffness methods. Now, when we deal with stiffness, it's the rigidity of a structure that prevents excessive deflection or deformation. Then finally, material selection. And this happens to be one of the most important items because choosing appropriate materials, they're going to be based on their properties and performance. So break everything down. Stability. Stability is a fundamental principle and cornerstone in structural design. It ensures a structure remains balanced and secure under various loads and forces. So basically, what I'm going to tell you when we deal with stability, it involves designing foundations that can withstand vertical and horizontal forces and incorporating bracing and support systems for lateral stability. So consider the construction of a tall building or a skyscraper. Well, just as I discussed earlier in foundations, if you don't have a stable foundation, the entire structure is at risk, no matter what your design looks like on paper aesthetically, no matter how well built the other parts might be. Similarly, stability could refer to a well-defined project plan. For instance, if you're launching a new marketing campaign, the stability of your project could hinge on a comprehensive plan that outlines clear goals, specific tasks, a realistic timeline, and designated resources. And we get into strength and stiffness. The strength and stiffness of a structure are essential to withstand applied loads and prevent excessive deflection and deformation. And what engineers do is they consider factors such as material strengths or strength, cross-sectional dimensions and connections so that the structure can support the required loads without failure. Because if there's a failure in the structure, believe me, just like that walkway that collapsed in Kansas City and that bridge that collapsed in Baltimore after a ship hit it, and the other building that collapsed at the University of Miami, going to be failures. And in construction, there are failures. Now, in project management, these principles can be viewed as the robustness and adaptivity, or let's call it the adaptability of your project plan strategy. So in project management, these principles can be viewed as the robustness and adaptability of your project plan strategy. So just imagine that you're planning a large scale software development project. Well, the strength of your project structure can be seen in a robust project plan that clearly outlines the tasks, assigns roles, and sets milestones. So much like a strong building structure, this plan can withstand the pressures of the project, such as tight deadlines or complex tasks. And also, finally, we deal with material constructions and structural design. So choosing the suitable materials, whether steel, concrete, timber, composite materials, or a combination, is key to structural design. Basically, factors such as strength, durability, cost, and environmental impact are key considerations since each material has unique properties and advantages. For example, steel is known for its high strength to weight ratio, making it suitable for structures that require high load bearing capacity. However, concrete offers excellent durability and fire resistance by making it ideal for building foundations and structures that need to withstand harsh environmental conditions. So material considerations in structural design translate into resource considerations in project management. So considering or choosing, let's say choosing the right sources. I like choosing a lot better because it actually flows into obtaining the correct materials. And when you choose something, you're actually making a decision. So when it comes to any construction project, whether it's structural or highway, got to choose the right resources. Much like selecting the suitable materials, it's crucial for the success of your project. So what I'm going to do, I'm going to go ahead and let me see if I got a video and fair use. I'm going to show you what some engineers do. And show you what structural engineering is about. Fair use, fair use.
Dutch Boy Professional Series. Trust your business to the paint partner that works hard for you. Available at Menards.
My husband, Bob, has Parkinson's. He needs more help, and I need more support. With Indiana...
G'day. Today, if you watch this episode, you'll find a little bit about what structural engineering is and what we do as structural engineers. My name is Brendan, and I'm a structural engineer for over 15 years. And in this channel, I'll be providing technical advice on how you approach designs as a structural engineer and a little bit how to progress your career faster as in the structural engineering field. As a structural engineer, where do you start? You start at university in a degree called civil engineering. Now, civil engineering is a really broad topic that ranges in breadth, as it has anything to do with constructing a city. So whether that be the water systems, the road systems, or even buildings. Today, I'm going to be focusing on buildings as a structural engineer because that's really where I fit in my career. Structural engineering is a broad topic in itself, as you can start at some of the very smallest structures to some of the biggest you see in the world. So some of the tallest skyscrapers, some of the biggest stadiums, some of the longest bridges. So we can either be involved with structures or even infrastructure work. Who is involved with building design? When you look at a building, you need a number of professionals to come together to create the final product that is that structure. Now, these range from the structural engineer, what I am, an architect, that makes the look of the building and how people interact with the building, the mechanical engineer, that has to do with the airflow in the building and making sure that people are comfortable inside, the hydraulic engineer, that has to do with the water in and out of that structure, and the electrical engineer, which obviously provides lighting, any electrical ports inside and out. Now, they're the primary people that are involved with the building. There's also other engineers to a lesser extent, but these are the primary functions that you need to ensure that you get an operational building. Now, I'm going to be focusing on the difference between what an architect does and what a structural engineer does. So what a structural engineer does, they essentially design the bones of the building or the substructure that's involved with like columns, rafters, and other elements that help stabilize that building, where the architect is involved with the overall fabric and how people interact with that building. So often when we build our drawings, and what we look at as a structural engineer is often covered up by the facade that the architect encases that structure in. Structural engineers, what do we do? Structural engineers, we need to make sure that the structure is able to withstand any forces that may see through its lifetime. And these forces are broken into really two main primary aspects. These are either gravity forces or lateral forces. Gravity forces are pretty self-explanatory. So they are anything that's within the structure that causes weight in the structures. These are broken into a number of different subcategories as well. You have dead load and self-superimposed dead load, which is normally permanently on the structure. So these are things like the substructure of the building and also finishes and facades. And we have live loads that are transient in nature. They're things like people moving in and out of the building. Now there are lateral loads that are perpendicular to gravity. These are things like earthquake and wind and even out-of-balance soil loads that cause the structure to move sideways. We have to make sure that we account all of these forces in our design to ensure the structure is stable. The skills required to be a structural engineer. As a structural engineer, you need to be good at maths and physics, as that's primarily where you're going to focus your technical aspects of your career. You also need to be good at problem solving and solving puzzles, because a lot of the time you'll have a problem that's thrown by the architect. They want to achieve some aspect of their design, and it's not necessarily a clear way that you can actually see that solution. So looking at potentially out-of-the-box solutions and different ways that you can achieve the way what the architect wants to achieve. One of the ideas I like to smash is that engineering is not creative. I think this is not true at all. Because when you think about some of the best designs, they have to be truly innovative. This is what makes engineering an art form and really hard to master. Now, this can also be seen in some of the great churches that are built around the world, where some of the best architects and some of the most creative minds that you can see have created masterpieces, where they also had to be architects, but they also had to be engineers to be able to build the masterpieces that you can see today. None other than the Sacra Familia made by Gaudi in Spain. It's really a marvel to see the eye, and has pushed the boundaries of structural engineering even today. The responsibility a structural engineer has. When you design a building, you have the ability to affect many people's lives. As whether it's an office space, you potentially affect someone's work, whether it's someone's house where they live, somewhere where they've built their home. So when you work out in the structural engineer, you should hold your head with pride with the ability of the work that you do and the way that you affect society around you. A bit about me. I'll give a little bit about me. My name is Brendan Hasty, and I'm a structural engineer in Australia. I've worked all up and down the east coast of Australia, starting in Melbourne. I've worked in Brisbane, Sydney and Canberra. I've done a number of projects in Adelaide, Darwin, and all the way across to the west in Perth. This gives me a breadth of knowledge that I hope to impart to you. My knowledge ranges from timber, concrete, composite, steel, and even into some rehabilitations of buildings as well, and done some work on heritage listed buildings that I hope to give all that information across in the many episodes that I like to see into the future. Anyway, thanks for watching. If you did enjoy this, there'll be more of these topics coming out, so please don't forget to like, comment and subscribe. And if you have any differences of opinions on what structural engineers do, or any topics you'd like me to cover, please comment below and I'll get back to you as soon as I can. Anyway, thanks for watching and look forward to seeing you in the next episode.
And again, if you are interested in structural engineering, Brendan Hasty is his name. He's from Australia. Like, share, and subscribe to his channel, and I'll be featuring some more individuals on my channel. And one of these days, I'm going to try to reach out and have some live panels on this side where we're going to talk about engineering, because, again, a number of individuals don't believe engineering is an art. It's not as artsy as architecture, but you saw some of the structures that were in this video, and some bright minds and some innovation that came together to construct some of the world's most beautiful structures out there. That's really what drove me to civil engineering. I mean, I started off in the hotel and restaurant business, actually developing a menu, cooking. Because if you think about it, You look at people like Chef Ramsay, Guy Fieri, some of your other cooks out there. You have to have an innovative mind to actually design something, to market it, to sell it, and make sure it is safe. Well, that's what I've done in my field. Now, I manage a lot of projects, have some design experience, but basically, when it comes to structural design, structural design goes well with structural engineering. And again, with structural, with infrastructure, they're all critical. Because in the end, when you deal with structures, you want to make sure that you have a good foundation. You want to make sure that your soil is good. Because if you have bad soil, building is going to move, it's going to collapse. Look at the Leaning Tower, Pisa. They have to underpin. And that's a beautiful structure. But there was a failure in the foundation. It's one thing you have to be careful when you deal with structural design. You have to know your calculations. You have to know your physics. Again, you have to know about different loads. You have to know about moments. You have to know if your structure is statically determinate or statically indeterminate. Like what I said before, if you have a statically indeterminate structure, you basically have more moments than unknowns or more unknowns than moments. Well, when we deal with something that's static, your moments, your reactions, they all add up to equal zero. I'm talking about forces, moments in the X direction and in the Y direction, all taking statics. Like I said, most people, when we talk about structural design, they're looking at it as it's all CAD. No, you can do a sketch, but it's the calculations, it's the specs you're going to use, it's the items, it's the materials. Talked about the stiffness, the load bearing capacity. Because after all, it comes to structural design, you want a building that looks good, but you want a building that's safe. Because after all, a proper structure means you have proper safety. And proper safety means no loss of life. That's why we have specifications. That's why we have engineers who are licensed, so we don't run into differential settling where you have cracked foundations. Because again, when they're actually drilling, you want to drill down the bedrock because you have geologists involved as well and geotechnical engineers. Structural design is, believe it or not, in many areas. Think about this. Engineering is a science. So, to better understand structural engineering, take some courses. Understand that you must know your math and science. You must know how to read plans and specifications. Because after all, engineers, part of your infrastructure that you live in, eat in, travel to, drive on. There's a structural engineer that had their hands into designing that piece of infrastructure so we can all go about our everyday lives safely. And that concludes this topic on innovations of structural design. If you like what I just presented, comment, share, and subscribe. And if you are looking for some social content, political content, check out my main channel, the 411 Talk Zone radio show channel, which is also on YouTube. Now, once I complete recording all of my videos, then I post my videos on my Twitter page. Now, since this channel, the QCIS channel, is more education based, that channel is also posted on my LinkedIn page. And like I said, anybody who's coming to my LinkedIn page, if you're not going to talk to me about engineering, science, because that's why I post my videos, don't reach out to me. I know some people have reached out to me and said I have a nice resume. Well, my resume is not going to get me interested in talking to you. This is not a social site. I put this up for people who are interested in STEM. That's why I created this channel. If you're looking for some social content, well, this channel is not for you. That's why I call it the QCIS channel. Quality control here. So, again, all my educational content from this channel, QCIS channel, goes right to my LinkedIn page. And once again, thank you for viewing this content from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.